Hello ladies and gentlemen, welcome back to math. Today we're going to continue working with polar form and rectangular form. Last class we were working with multiplication. Today we're doing division, okay? So keep in mind, I kind of have the same equation we used last class. The only difference is when dividing two polar forms, okay? When combining them, should I say. We have R1. Last class it was R1 times R2. Today we're doing R1 divided by R2, which is our radius. Okay. Our cosines last class was theta 1 plus theta 2. Today for division is minus. Okay. And then we have a plus between the cosine and the sine. Last class, this time we have a minus for division. And then obviously again, we have a subtraction and division for sine of theta 1 minus theta 2. Last class for multiplication was for plus. Today is a minus. Okay? So kind of multiplication and division. Multiplication is mostly positive. Division is mostly negative. Okay? That's the difference. So our objective is kind of still the same. The objective is to combine the polar equations. Okay? Then convert them into rectangular form. Okay? Remember, rectangular form is A plus BI or A minus BI. Okay? We're going to use the same problems we used last class, which means that for your assignment for today, it's going to be using the same problems you used last class, the ones I gave you, to convert them, this time by division instead of multiplication. Okay? Alright, so let me write them on the board. Alright guys, keep in mind I have the exact same problems we used last class, okay? I had 4 cosine of 60 plus I sine of 60. 2 cosine 30 plus I sine of 30. That was our first problem. And then obviously our second problem was 2 cosine theta over 2 plus I sine pi over 2, should I mean. Okay? And then 2 cosine of 3 pi over 2 plus I sine 3 pi over 2. Okay? Those were the two problems we did last class. Last class we multiplied. Today we're going to divide. Okay? So the first things first. So we have to recreate kind of the problem on this new form. So therefore we have 4, which is our R1. So 4 divided by our second one, which in this case is 2. Cosine, let's use the big brackets here. Cosine of theta 1, which is 60, okay, minus 30, because remember, it's the first one minus the second one, plus, or in this case is minus I sine, I forgot to put that, I sine theta 1, which is 60 minus 30. Okay? Alright, 4 divided by 2 is 2. Okay? So 4, or 2 can go to 4 2 times. So 2 cosine of 60 minus 30, which in this case 60 minus 30 is just 30, minus I sine of, again, 60 minus 30 is just 30. Keep in mind, your sine and cosine on your equation are always the same in degree form or radian form. Okay? It might change in cosine itself and sine depending on the degree or radian, but when dealing with the degree and radian form, it's always the same on both, the sine and the cosine. Okay? Alright, so now we can convert cosine and sine, okay, of 30 degrees. Okay, if we look at the unit circle, 30 degrees for cosine and sine. Okay, we have our unit circle right here. We have 30 degrees, which if you guys can see, it's right there, 30 degrees. So cosine and sine, cosine is radical of 3 over 2, and sine is 1/2. Okay, so we're going to write that in. So we have 2 times radical of 3 over 2 minus I, or 1/2 I. This time it goes on the back. Okay? And then we distribute the 2 times both, which the first part is 2 radical of 3 over 2 minus 2 over 2 I, which technically the 2's cancel out here. We're left with radical of 3, and then the 2's become a 1, or just 1I, or radical of 3 minus I. Either one works, okay? You can say it as radical of 3 minus 1I, or radical of 3 minus I. It's up to you. Because remember, 2 can go to 2 one time. Okay? So that's one problem. Alright, let's do the other one. So again, we kind of do the same thing we have up here. Again, we set it up. We have 2 divided by 2. Okay? Which technically 2 divided by 2 is what? 1, right? So we can technically already save that piece. So we can say 1 cosine of the first times the second one, or minus the second one, okay? Which in this case, if you want to, okay, it's up to you. You can either subtract them as they are, or convert them into degrees, okay? So what's 1/2, or pi over 2? It's 90, right? So 90 minus 3 pi over 2, which in this case is 270, okay? 270 minus I sine, again, of 90. I ran out of space here. Stays the same. 90 minus 270. So now we're dealing with 1 cosine of negative, okay? 90 minus 270 is, let me see from the calculator, 90 minus 270, negative 180, okay? Negative 180. And again, since we're dealing with degrees, we're going to have the same thing, okay? Minus I sine of negative 180. Keep in mind, guys, okay? 1 negative of 180, it's still saying the opposite from 360, okay? So we subtract 360, or in this case we add 360, we have negative 180 plus 360 is still positive 180, okay? Remember those switching angles with positive or negative 360? In this case, since we're dealing with the negative, we're dealing with 360, and then we go backwards to 180. Technically, it's still the same, right? Because 180 is halfway. So technically, it's still negative 1 and 0. Okay, as sine as cosine. So we have cosine is negative 1 minus 0i, right? Yep. We have 1 times negative 1 and 1 times negative 0. Okay? So 1 times negative 1 is just negative 1. Since there's no number here and the imaginary is just 0, there is no number there. So 1 times 0 is just 0. So technically your answer is just negative 1. Okay? Again, the reason why we have negative 1 and 0 is because whenever you have a negative number, okay, you start off on 360 form. You go backwards. Think of a counterclockwise, okay? You start off at, well, technically, here's counterclockwise at 0, because you go this way, and then the clock goes this way. So think of clockwise, should I say, okay? The unit circle is read counterclockwise, but when dealing with negative, think of a clock. It goes the opposite. It goes from here, from 360, backwards. Since we're negative 180, we stop over here at 180. So technically, it's still negative 1 and 0. Okay, that's why we still got negative 1 and 0. Alright guys, so your assignment for today is, first of all, make sure you have all the notes. Okay. Secondly, I want you guys to use the same problems I gave you last class. If you haven't seen the video from last class, watch that video first. Okay. Send me those answers for those problems I gave you last class, but this time with this equation, with the division equation, okay? Alright guys, make sure you submit your answers as soon as you're done watching the video, and I'll be here waiting for your email.